The law of sines. The law of sines states that in any triangle, the ratios of the sine of any angle to the side opposite that angle are equal around the triangle. Thus, given a triangle with angles A, B, and C and sides A, B, and C, sine A over A is equal to sine B over B is equal to sine C over C. This is also true with the reciprocal of these ratios. In this video, you will prove this relationship. Given a triangle, you can name this triangle triangle ABC and the lengths of the sides as A, B, and C respectively. Always use capital letters for the angles and the corresponding lowercase letters for the opposite sides. To derive the law of sines, you can draw an altitude from one of the vertices. In this case, draw an altitude from vertex C. Call the length of that altitude h and its intersection with side AB, point D. Now you have two right triangles, triangle ADC and triangle BDC. In triangle ADC, the sine of angle A is equal to h over b, since sine is equal to the opposite side over the hypotenuse. You can multiply both sides of this equation by b to isolate h. You have b times sine A is equal to h. In the same way, in triangle BDC, sine of angle B is equal to h over A. You can multiply both sides of this equation by a to isolate h. You have a times sine B is equal to h. Notice that you now have two equations that say b sine A and a sine B are both equal to h. By transitive property, b sine A is equal to a sine B. You can now divide both sides of this equation by AB. This will cancel b from the left side and a from the right side. Consequently, you have sine A over A is equal to sine B over B. You can repeat the same process by drawing the altitude from vertex A. You will be able to show that sine B over B is equal to sine C over C to complete the equation of the law of sines. Remember that in order to apply the law of sines, you only need the proportion between two side angle pairs. Pause or replay this video to catch up with your notes, or go back to any part that you did not quite understand. Watch the video examples showing how to apply the law of sines in solving triangles.